just slightly before 2:30. Maybe I can just ask someone just to give a thumbs up in the chat, just to confirm that you can hear and see. Great, thanks very much. That's awesome. Right, it is 2:30 now, so we'll get going. Welcome back, everyone. Yeah, thank you for coming back, and I hope these are proving to be useful. I'm really amped and excited about today's one, the sort of maths of money, and I think just about everyone's interested in that. So, but there's also some really cool maths involved. So, without too much further ado, let's dive in. But just a quick reminder about how it works in case there's anyone watching for the first time. Um, the problems I'm going to solve are available at simi.education. You can download them beforehand. You can try them yourself, and that's definitely the best way to kind of go. And then straight after the session each day, I'll publish the full worked solutions. If you do watch the video afterwards, in other words, after the fact, a recording, please watch it actively. And by that, I mean, don't just sort of put your music on and kind of let it drone away in the background. Actually pause it, try the question, pause it, at least think how you would do it yourself before letting the video play. All right, really try and engage. Okay, let's dive in. So first up, and as I've done on previous occasions, we're going to just look at kind of what formulae do we get given. All right, and we get a total of 6 of them, and in fact I've only put 4 of them up on this slide, but I'm going to talk about the other 2 as we get to them. There are 4 that involve 2 of them involve appreciation, the top 2, and then 2 involve depreciation. Appreciation is when something gains value, and the A value would always be bigger than the P value, and depreciation is when something loses value, and the A value would be smaller than the P value. Right. Remember, P is your sort of starting value and A is your final value. It's quite easy to remember which ones are which, because the ones which appreciate have got plus signs in them, and the ones which depreciate have got minus signs in them. Right. And there's essentially kind of straight line appreciation or depreciation, and then there's compound appreciation or depreciation. But compound depreciation we call reducing balance, and it's important that reducing balance depreciation always happens annually. All right, and then inflation, unfortunately, is compound rather than simple, and it also happens annually. Okay, I'm going to, and I haven't actually got the formulas. I've realized on the slide, but the main sort of part of the matric maths are the present value and the future value formulae. I haven't actually got what they are there, but the really important thing with these is to understand exactly what they tell us. Start with the future value formula. What it does, because in fact with both these formulas, what's happening is we're making payments of X, regular equal payments, all right, equally spaced and equal, all right, and in both cases we're making those payments into the future, right. The future value formula, as the name would suggest, tells us the value of all those payments with interest as the last payment is made. Okay, so in fact, the last payment doesn't gain any interest at all. The penultimate, the second last payment, actually is only in the account for 1 month. The third last is actually in the account for 2 months. The formula takes care of all of it, but just remember what it tells us. It tells us the value of those payments as the last payment is made. The present value formula, as the name suggests, tells us the value of all those payments that are made in the future, but it tells us their value today with the assumption that the first one is not being made today, it's being made in a month's time. Right. So I think this image is reversed, so in a month's time. Okay, so really, really important to understand that actually that the first payment is a month away. Right, and as we know, present values for repaying loans. We'll talk a little bit more about them just now. Okay, we're going to dive in and we're going to look at just some basics, really, just to start off with. Okay, and the first fundamental thing is the whole idea of percentages in maths, in financial maths, and increasing numbers in a given percentage. So if I said to you, for example, increase, let's just say 750 by 8%, right? I think all of us would know how to do that, but I want to just show you a quick and sort of obvious way that really makes all of this stuff make sense, all right? I think the obvious thing to do would be to work out 8% of 750, all right? And then we would have to add to that 750. So we'd take 750 and we would add 8% of it. Now, if we factor out the 750, what actually happens is we get 750 and then we get 1 plus and 8%, obviously 0.08. So in fact, what we get is we get 750 multiplied by 1.08. 1.08 is what I call a multiplier. All right, I'm just going to highlight it yellow here. I was going to try and highlight it yellow, but we ended up rubbing it out. Let's try that again. I'm going to highlight it yellow. All right, and it's a multiplier. It's bigger than 1, and that's why this thing is increasing. It's also, and it makes perfect sense that it's the right multiplier. It is also 1.08 is actually 108%. Okay, now let's just, while we're here, I just want to quickly do a similar thing, but with a reduction. If I said to you, let's decrease, say 800 Rand by 11%. All right. Then what we would do is we would take our 800 and we would take away 11% of 800. Once again, if we factor out the 800, we actually get 1 minus 0.11. And we in fact end up with our 800 being multiplied. Again, we've got a multiplier. This time our multiplier is 0.89. All right, and again, it makes perfect sense that it would be 0.89 because our multiplier is now less than 1, right? Because we are actually reducing, all right? And that's our multiplier there. And that multiplier, obviously, is actually 89%, right? And it makes sense that if you're going to reduce something by 11%, that you would be left with 89%. So a multiplier of 0.89. Okay, we're going to dive in now into our questions. And this topic is actually called finance and growth. So questions can be asked that are actually not about money at all. And so the very first one I've chosen is not about money. It says water weed in a dam increases by 6% per month. If the initial area covered by weed is 20 meters squared, what will be the area covered after 8 months? Well, after 1 month, right, after 1 month, we're going to grow our 20 meters by 6%. So I'm going to use a multiplier of 1.06. Right, so that's after 1 month. After 2 months, what will happen is this is the amount of weed in the dam, all right, after 1 month, and then that gets multiplied by 1.06. So what we can see here is obviously kind of sort of compounding or continuous multiplying because this here is after 1 month, and then we multiply by 1.06. So after 3 months, it will obviously be 20 times 1.06 squared. That's after 2 months. And then to get from 2 months to 3 months, we're going to multiply by 1.06 again. And I'm hoping you're seeing why the compound interest formula actually works. So in fact, after 8 months, we don't need to write all those down, but after 8, we're just going to get 20 times 1,06 to the power of 8. Okay, and we get our answer of 31,88 meters squared. In a sense, there's not really a formula for that. It's actually an application of geometric series, which is obviously one of the topics that's coming up on these semi-live streams. Okay. A share portfolio loses 3% of its value each year. If it's initially worth 27,000, what will it be worth after 10 years? Well, after 1 year, we're going to take our 27,000 and we're going to, now if we want to lose 3%, what's our multiplier? Anyone want to just type into the chat? What would our multiplier be? And I'll give you a hint, it's less than 1. Our multiplier, if we're losing 3%, I'm just looking to see if the chat is sufficiently live that anyone's going to give me a multiplier here. I'll tell you it's 0, something. All right. Okay, I'm not seeing any answers, so I'm going to carry on so as not to bore people. But 0,97. All right, that will be our multiplier. All right. So now, if we after 1 month, it'll be 27,000 times 0,97 to the 1. After 2 months, it would be to the power of 2, and after 10, sorry, no, we're not talking about months at all, we talk about years. After 10 years, it would be 0,97 to the power of 10. So we can once again bring up our calculator, and our answer is going to be 27,000 times 0,97 to the power of 10. Okay, and I get 19,910 and 45 cents. Remember, we are always, there I'm seeing some multipliers there, and I'm seeing some correct ones and some incorrect ones. All right, the correct one is 0,97. 0,03, we'd be taking 97% off because we'd only be having our 3%. Right, so 19,910, sorry, I keep forgetting this number, 0.45. In financial maths, we always round to the nearest cent. Okay, right, let's dive into another one. Now this question here, I need to tell you that about half the educated adult population of the world gets this question wrong, right? And the reason they get it wrong is they look at this thing and they say, well, let's work out what 15% of this is. And that's completely wrong, because the VAT wasn't worked out on this. The VAT was worked out on another number. What is the multiplier if our price is P? What would be the multiplier to add 15% to P? And again, I'm looking in the chat to see if anyone's got an answer for us here. All right, so in other words, to grow P by 15%. And because we're growing P by 15%, right, this is the price before VAT. Because we're growing P by 15%, we're going to multiply by a multiplier to get our final answer, 397,44. I can tell you that multiplier is bigger than 1. And again, there's obviously a lag. Thank you very much. And I don't know how it's pronounced, Nana, but thank you very much. Well done. Our multiplier is 1,15. So, folks, it's really a very basic equation here. We know that whatever our price was, to get the VAT put on of 15%, that's the multiplier, all right? And so, in fact, to get back to P, I'm just going to divide both sides by 397,44. So P is going to be 397,44 divided by 1,15. All right, and I promise you, many adults, and tragically even many maths teachers, don't necessarily get this question right. 397.44 divided by 1.15. This multiplier idea is really quite powerful, and we get 345 Rand and 60 cents. Okay, right, on to the next question, question number 4. Now, this is a really interesting question as well, and again, you can probably win yourself some money at a sort of a quiz, or on Who Wants to Be a Millionaire? A shopkeeper marks up an item by 20%, but then offers a 20% discount. What's her net profit or loss expressed as a percentage, or doesn't it make any difference? And I can tell you that the knee-jerk wrong answer is, oh, well, it will make no difference. She'll be back to where she started if she added 20% and then removed 20%. Not true. The 20% are of different amounts. Okay, so what we've got here, let's take the item. Suppose the item costs P for price. How will we mark it up by 20%? We will multiply it by 1,2. All right, that's the multiplier. That's a multiplier bigger than 1. Now that is our marked up price. What will we multiply it by to mark it down by 20%? Remember, if we want to mark it down by 20%, we only want 80% of the value. When we're marking down, our multiplier is it's always less than 1. Sorry, so this is going to be 0,8. All right, now, if we take P and we work out what the combination of these two multipliers is, in other words, we multiply the multipliers, all right, we actually get 0,96. 0,96. Now, is 0,96 going to lead to an overall reduction or an overall increase in P? Right? And we need to just think about this, right? It's smaller than 1, and in fact, it's 4% less than 1. So what will happen if she does this, if the shopkeeper does this? She actually will end up with a 4% loss. All right. Another interesting question about discounts and markups is kind of, does it matter which one you apply first? And it doesn't, because remember, mathematics, the law of multiplication is commutative. In other words, it doesn't matter whether you apply the discount first and then the markup, or the other way around. Okay, right. So that was really some basic sort of background stuff, but very, very important in terms of understanding sort of the mechanics of this. Let's now look at a sort of specific example. All right. An item depreciates at 8% per annum according to the reducing balance method. Remember, the reducing balance method is the compound one. So it's this one, 1 minus I to the n. All right. After how many years to the nearest year will it be worth a quarter of its original value, 25% of its original value? Now, a lot of people will want to use numbers here, and that's okay. But you might say, well, let's put 100 Rand in here, all right? But in fact, if we put P in here, all right, so if we put 100 Rand in here, we would put 25 Rand here. But if we put P in here, then clearly 25% of P would be 0.25 P. Right, so we kind of not resorting to numbers. We're sticking with variables, right? Remember that the depreciation is 0.08. Just careful, a common error people make is they think 8% is 0.8. 0.8 is 80%, huh? All right, and this is to the power of n. Okay, now you'll notice that that the P doesn't actually matter because the P will divide out. So what we end up with here is we get a quarter on the left-hand side, irrespective. If we'd use 25 Rand, depreciating from 100 Rand, we would have got a quarter. If we'd used 8 Rand here and 2 Rand here, we would have got a quarter. If we'd used 4 Rand here, or even 4 cents here, 1 cent here, we get a quarter. So now we've got 0.92 to the power of n, okay, and we are now solving an equation that involves logs, okay? Remember when we did equations, I said everything's connected to everything else in maths. We need to be able to take this out of exponent form and into log form. And one of the things that I said, one of my sort of refrains, my battle cries, is that the base is always the base. So there's the base, there's the base, okay? And obviously now what we've got is we've got n equals n equals log base that of that. Right. And our answer, well, let's in fact get our calculator out and see what our answer is. Okay, log base 0.92 of 0.25, and we get 16.6, about 16.6 years. Right. So it actually says, I'm not reading my own question, it actually says to the nearest year, right? So 17 years. Okay. Right. Next up, what annual rate, this is now about nominal and effective rates, what annual rate compounded quarterly will give the same return as 10% per annum compounded semi-annually, in other words, every 6 months. So these are actually both nominal rates. I'm going to show you how I like to do this. We're just going to use this formula, and I'm going to consider investing R1 for 1 year. All right, just R1 for just 1 year. Now, what I'm going to do, just to hopefully make this sort of a bit simpler, is I'm going to use two different colors. So I've got that, and I've got this. Okay, so in the right-hand corner, in the green boxing shorts, here's the answer to that. So all right, R1 will become, if I invest R1 for 1 year and I compound the interest semi-annually, in other words, twice per year, I'll actually end up getting 5% each half year, and it will be worked out twice. So at the end of the year, that's how much I'll have, right? And I'm going to quickly work out what that number is, because it's actually quite a straightforward number. It's just 1 plus, sorry, it's 1 plus 0. Sorry, I'm not seeing my calculator now. 1 plus 0, 0.05 squared. Right. It's actually going to become R1, 1025. 1.1025. Okay. You might say, are we worried about this 2025? Mathematicians love accuracy, all right? And in this financial maths, the accuracy is really, really important. So I'm just going to show you this, all right? Work accurately. I love accuracy, all right? And I'm hoping you appreciate why that's maybe slightly amusing for me anyway, all right? Is because what we've got there is we haven't got our normal sort of red heart. We've got an accurate heart. Okay. So let's make sure that we are working accurately. Okay, now on the other side, okay, with the red pen, I'm going to fill in what I know. I know that I've got R1 again. I've got an interest rate which I don't know, but I know that that interest rate is going to be applied 4 times in the year, so I need to divide by 4, and it's going to be calculated. The interest will be calculated 4 times. So now I've got an equation. And I've only got one variable left in this equation. So on the left-hand side, I've actually got 1 plus I over 4 to the power of 4, right? I can take the 4th root. It's one way of thinking about it. Or I could take I could raise both sides to the power of a quarter. Okay. Because remember, if I raise both sides to the power of a quarter, when I raise the power to a power, the powers multiply, and I'll just be left here with 1 plus I over 4. If I do that on the left, I must do it on the right. 1.1025 to the quarter, right? I now need to subtract 1 from both sides. Remember our equation stuff from the other day? If you haven't watched that video, I really recommend that you do. Many hundred people have, which is very gratifying. Subtract 1, and then lastly, divide both sides by, multiply both sides by 4, goodness. Okay, so 1.1025 to the power of a quarter minus 1 times by 4. I'm going to get that number on my calculator. Now, I want to show you a little strategy, a little trick on your calculator here. Remember that number, that was 1.1025, okay? It's on screen here already, so I'm going to take that and I'm going to raise that to the power of a quarter. I'm then going to subtract 1, press equals, and then I'm going to multiply by 4. Right, and I get that. Now that is the percentage, all right? I'm going to store this percentage. I'm going to show you how to store a number on your calculator. I'm sure you do know, but shift and then this button here, STO, store, all right? And then you choose one of the red letters. I'm actually going to choose A, all right? And I've put that answer in A. Okay, so that exact answer with all the accuracy is in A. Okay, and I can press all clear. If I want that number back, I can just go recall A. All right, what it is, it's 9,878. So it's actually 9,88%, right? 9,8, because the question asks us for 2 decimal places like it. Okay, notice that because I'm compounding more often, I actually need a slightly lower interest rate. Now I want to show you something here. Remember when we invested R1 at 10% compounded twice in the year, we got this number over here, 1,1025. I'm just going to highlight it yellow, this number there. Okay, and now what I'm going to do, I'm going to take R1 and I'm going to compound. Sorry, I'm going to take R1 and I'm going to press equals. All right. What's happened now is that in my calculator's memory is R1. Okay. Now what I'm going to do is I'm going to take answer, which is R1, and I'm going to multiply by 1 plus my interest rate, which is in A, divided by 4. Right. So what's happening now is that my R1 is going to be grown by a quarter of that annual rate. And so after 1/4, I will have that much. Now the clever thing is that this number here, because I've pressed equals, this number is now in the calculator memory. If I press equals again, the calculator will do that calculation again, but this time it will grow this number by a quarter of my annual rate. So that's how much I'll have after 2/4. And after 3/4, I'll have that much. And after 4/4, I'll have that much, which, if you remember, was exactly the highlighted yellow figure. Okay, so these two rates achieve exactly the same thing. All right, let's put the calculator away for now, and let's dive on to our next question. Okay, and this is not often asked in matric maths. It's more kind of grade 11 stuff. And in fact, I'm not going to do this entire question. It is going to be in the full memo, but in fact, this particular question becomes massively problematic. But I do want to give you a little bit of a hint as to how you can make these timeline questions a whole lot easier for you. All right. So we've got a total of 5 years. Yeah, 5 years. This is T0. I am going to draw the timeline because I think that's quite important in just terms of understanding all of this stuff. This is T2, this is T3. It seems I can't count to 5. All right, so this is actually, if you'll excuse me, I'm just going to do that. All right, it's not great. Okay, so what actually happens is that Double deposits 2x here. 3 years later, he withdraws x. And 5 years, 5 years after his initial deposit, he ends up with 10,000 Rand. Okay. Then the interest rates do some different things, right? For the first 2 years, the interest rate is 11% per annum compounded quarterly. We can write that like that. You can either write 11% or 0.11. All right, that means compounded quarterly. All right, and then for the balance of the time, it's 10% compounded monthly for the first bit. and then 11% compounded quarterly. Sorry. So this is actually monthly, 10%, and then this is 11% quarterly. Right, now, if you work along the number line, in other words, you take your 2x and you put this interest on, compound interest, you can't, remember, you can never go past a change of circumstance. So you can't go whizzing along with your 2x straight to the end because the interest rate changes. So we need to actually just go as far as there with that interest rate, and then we'd go as far as there with this interest rate. Then we would subtract x. Then we would have to put big brackets around the entire thing and then put on the last bit of interest. What you will see is that our sort of x's are wrapped up inside brackets with lots of complicated stuff going on. In fact, the easiest way of dealing with these things is to consider the amounts separately. So I'm not going to finish the whole question, but I'll show you that what you can do is you can say, let's take 2x. All right, and what 2x will become after the 5 years, it will become 1 plus my interest rate of 10% over 12. I'm going up to 2 years. Now 2 years is 24 months. And then I'm still dealing with this money, this 2x. And now I'm going to put this interest on for the remaining 3 years. And that's going to be 1 plus 0,11 over 4. Now 3 years will be 12 quarters. Right. Now, that's what the original investment is worth. But the withdrawal I can actually do separately. And so that's going to be minus x. All right. And that only has 2 years of interest. In a sense, the lost opportunity of the withdrawal sort of loses the interest as well, if you like. So what we've got is we've got 1 plus 0,11 over 4, and this is now just for 2 years, 4 quarters a year, 8. Okay, now we know that all of that must come to 10,000. And the difference between the two approaches, if you look at the memo, I've done it both ways on the memo, is that the x's here are easily isolated. All right, it's easy to factor out an x, get everything else inside, and then solve for x. All right, for anyone who's actually tried the problem and wants to know the sort of final answer, it's 4,000. X is 4,000. So I'm just looking up at my memo, 4,678 and 20 cents, right? And there it is. Okay, as I said, I don't want to spend too long on this. It's actually quite unusual for a timeline question to come up. Okay, right. This is much more usual. This is now, Nonhlanhla, my friend, is depositing 3,000 Rand per month for 5 years into an account earning that. Right. First question we've got to ask ourselves is this a present value or a future value? Remember that future values are all around saving. Present values are all around loans, repaying loans. Right. This is definitely a future value. Nonhlanhla is saving money, depositing money, and it's asking how much will be in her account or is in her account at the end. Right. Here's the formula. It's the first time I'm showing it to you today, but it's future value is x, 1 plus I to the power of n minus 1 over I. Notice I'm not having to stop and think about the formula. If you use it often, I know you get provided it, but it's actually worth knowing it. Right. So Nonhlanhla is going to deposit 3,000. That's our x. 1 plus the interest rate is 0,09 over 12 because it's compounded monthly. And she's going to do this for 5 years. Now, 5 years will be 60 payments. N is the number of payments. All right. And so this now, and on the bottom here, we get 0,09 over 12. And let's just work out what all of that comes to. All right. it comes to 3,000. And there it is. It comes to 226, 272, and 41. 226, 272, and 41. Okay, but if you were paying attention earlier, you'll remember that little picture that I showed us, that what the future value formula does, it actually gives us the value as Nominal pays her last 3,000 Rand. So what we found is we found the value here. That's what that number there represents. Then it says how much is in the account 3 months after that. So now what we still need to do, all right, her final amount is actually going to just be not an annuity, just our normal compound interest formula, P1 plus I to the power of N for 3 months. Okay, so it's going to be 226,272,41, and I'm going, although I've written that number down there, when I do the calculation, I'm going to use the full accuracy, which is still on my calculator. And this is just going to be to the power of 3. Right. So our final answer here on this one, sorry, folks, I realize I've cut some stuff off on the screen on the top there. So times brackets 1 plus 0,09 over 12 to the power of 3, and I get 231, and here's where I now round off to the nearest cent. 231, 401, 82. 231, 401, and 82 cents. Okay, so that's a standard sort of investment type question. And savings future value. All right. Now here we're going to now talk about a loan. Before we dive into question 9, which is the loan, I want to talk to you about loans. All right. So here is the deal with the loan. There are two kind of role players here. There's the guy in the bottom left who's trying to find the money each month to repay the loan. And then there's the guy in the bottom right, the banker, who is collecting in the interest and making money out of lending the money in the first place. I've chosen nice, simple numbers here. All right, we're borrowing 100,000 Rand at 12% per annum compounded monthly. Now, what that means is 1% per month. All right, so the loan is 100,000 Rand. The chap bottom left borrows, let's give him a name, let's call him John. John borrows 100,000 Rand. He does not pay it back. He doesn't start paying back immediately. Otherwise, he wouldn't. If he paid back 1,000 Rand straight away, he wouldn't be borrowing 100,000 Rand. That's why, if you remember this picture, and I'm just going to go to it very quickly. If you remember this picture, our present value, our loan formula, is cleverly kind of positioned to only expect the first payment, the first repayment, to be in a month's time. Okay, so let's go back to my loan story here. All right, and so the interest is 1%. So what happens is the banker lends him the money and John's got the money for a month, right? And now 1% of 100,000 Rand, easily worked out, is 1,000 Rand. And so the banker says, right, I'm going to charge you 1,000 Rand for having this money for a month. Before John makes the payment, he now owes 101,000. His payment is 1,200 Rand, 1,200. So he now makes the payment, all right? And after he's made the payment, we'll see, in fact, that the loan is now 99,800. So it's a bit rough because he's paid in 1,200 Rand, but the loan has actually only reduced by 200 Rand. The good news for John now, though, okay, so that's the end of that month, and it's obviously the start of the next month. The good news now is that when the banker now calculates the interest, 1%, right? He doesn't calculate the 1% on the original amount. He calculates the 1% on what is still owing. So now the good news for John is that his interest has actually come down from 1,000 Rand to 998 Rand. Okay? Not great news, but there it is. Obviously, what happens next is that then gets added to what he owes. He makes the same payment, and that's the important thing about annuities. The payment's fixed, all right, and he gets his new balance. Okay, and the balance at the end of the month, obviously, that's the start of the new month. Now, 1% of that is now 995. So what you can see is that gradually the amount of interest being charged each month is reducing, and the balance of the payment is going to what we call capital. Now, I want to show you one last little schematic, and that's this one over here. At any stage in a loan, you can work out an outstanding balance, and we're gonna do that right now, okay? And you can work out an outstanding balance at a different point. The amount of money that outstanding balance changes by, all right? In other words, what we still owe changes by is what we call capital. The balance of the payments that were made in that time is interest. So I want you just to think, and it would be nice if I had created a slide for this, but I want you to think about a loan that runs its full course. When the loan starts, the outstanding balance is, say, trying to work out which finger's on the left here. It's the wrong one. Okay. Yeah, I'm not sure. And when the loan starts, say 100,000 Rand is owed, and when the loan is finished, nothing is owed. So 100,000 is what we call capital. If we take the total of all our repayments, the amount that exceeds the capital by, in other words, the difference, will be interest. Okay, but we're going to look at an example. Well, we're going to look at this example right now. Okay, so Nele, my friend down near Mzumbi, he borrows 100,000 Rand. He repays it with monthly repayments over 5 years, starting 1 month from the date of the loan. That's very standard. That's normal. All right, and interest is charged at 12% per annum compounded monthly. So this is our present value formula. I'm just going to write it in here. Present value is x, 1 plus I. No, it's not at all. Sorry, it's 1 plus I. It's 1 minus brackets 1 plus I to the negative n over I. Okay, and that is, that's the formula. Now, what that formula is, it's going to give us the value of the present value of his payments. We don't know what those payments are, but the value of all his payments in today's terms must be the same as the value of the amount that he's borrowing. So in other words, you're going to put the 100,000 over here equals x, 1 minus 1 plus 0.12 over 12 to the power of negative 60. 5 years monthly payments. And over here, we're going to get 0.12 over 12. Okay. And to save time, I happen to know the answer to this question. It's one that I use quite often. It's actually 3 2's followed by 4.2, 2 more 4's. All right, that's rounded off to the nearest cent. It's 222.444. That's his monthly repayment. Right. Now we've got the question, how much does he still owe after making his 36th payment? Now, there are 2 methods of working this out. All right. In the case where we know exactly how many payments he's got to make and how many he has made, and we've worked it out exactly, we can find out the present value. In other words, we can use this formula of the outstanding payments. So if he's made 36 payments, sorry, doing it again there, cutting my writing off, outstanding payments. If he's made 36, then it would actually be the present value of 24 outstanding payments. And that would be really simple to work out because we just put our payment value in there, and our end value would be so payment value, yeah, where X is, and our end value would be minus what would be 24 there. Okay. Unfortunately, that method doesn't always work. It doesn't work if we exceed the minimum payment. It will work with this particular question, and you should try it. Try it both ways. If you are going to try it, make sure you use the full accuracy. In other words, you store that value in your calculator. Right? Then you'll have the satisfaction of getting exactly the same answer, not a similar answer, exactly the same answer. Remember, mathematicians love accuracy. Okay. A much safer thing to do, which always works, is to say that our outstanding balance is the loan with interest minus the value of the payments that have been made with interest. Now, important thing to notice here is that we're talking now in 36 months time. So we're actually talking about a future value. This over here is a future value. So the answer to this, the way we're going to work this out, we're going to take our loan, right? And we're going to put on 36 months worth of interest, 0.12 over 12 to the 36. And if you think about it, this method makes an enormous amount of sense. If the banker hadn't lent Sanele the money, this is what their money would be worth. The money that they've received from Sanele by way of repayments is worth 222.444. I'm doing my future value thing here. 1 plus 0.01. I'm hoping you're okay with me changing the 12 over 12 to 0.01. Sorry. To the power of 36 minus 1 over 0.01. Okay. And I'm going to repeat what I started saying. If the banker hadn't loaned the money, this is what the banker would have had. What the banker has got is what Sanele is paid, and so the difference must be what Sanele still owes. Okay, so it makes an enormous amount of sense. Okay, as maths always does. All right, izibalo ziqhaqheke injalo. Okay, so I'm going to just find the answer to this. It's actually 47,000. Sorry, my pen is working much better than last time. You'll notice 47,254 and 95 cents. Okay, that's how much he still owes. Now, one of the things that we can do really nice is we can model a loan on a spreadsheet. So I'm going to show you this particular loan on the spreadsheet. And it's exactly what I was showing you just now when I showed you that very simplistic example. All right. But there it is nonetheless. Okay, there's the 100,000 Rand, there's the repayment, and it's 1%. And we can see what's happening here is that we can see the balance after each payment. Now, I'm going to scroll down here and I'm going to find the balance after the 36th payment. And what you'll see, there it is there, it's exactly the number that we've just calculated. That is how much he still owes after that payment. Okay, I'm going to go back to, sorry, shifting the screens here. I'm going to go back to here. Then it says, how is his 37th payment split between interest and capital? Now remember the simple story of how a loan works. This is how much he owes after 36 months. So what the bank's going to do now, they're going to charge him 1/12 of 12%, because that's our rate. They're going to charge him 1% worth of interest in the next month on what he owes. Okay, so he actually 1% of 47,254.95. Even I can work out what that is without a calculator. We're just going to move the decimal place twice. We're going to get 472 and 55. 472 and 55. That's how much interest he's going to pay with the 37th payment. So as a percentage, he's going to pay 472.55 out of his payment of 2224.44 multiplied by 100. All right. And what we get 21.24. And that's 21.24%. And that is interest. Now that means that the balance of that payment, all right, and if we subtract this from 100, we get 78.76. That 37th payment, 21% of it went to interest and 78% roughly to capital. Okay, right. Now, how are his first 3 years of payments split between interest and capital? Again, I'm going to show you this little schematic here. All right. So initially, his outstanding balance was 100,000. That was at the beginning. Now his outstanding balance is 47,254.95. There it is, up at the top of the screen. Okay. So in total, in those first 3 years, the capital is going to be the difference between what he did owe at the start minus what he now owes. And so what we work out now is that is in fact 80,000. No, sorry, it's not 80,000 rand at all. It is 52,745 and 5 cents. That is how much the loan has come down by. That is what we call capital, right? But that capital was out of a contribution, in fact, 36 contributions of Sanele's monthly premium. So 36 times 222.444. This number on the bottom here, just for interest, it's around about 80,000. It's not exactly 80,000, right? And so we can see that of the 52,000 that Sanele is paid, the loan hasn't come down by, sorry, of the 80,000 that Sanele is paid, the loan's only come down by that much. All right. Okay. So the balance of that amount would be capital, would be interest. Sorry. This amount here is capital. Okay. This 52 number here. All right. If we work this out as a percentage, and I know I'm running off the screen there, but if I multiply that by 100, all right, what I actually get is I get very close to 66%. It's actually 65.87%. As I said, I do like the accuracy. And so basically, 65.87% went to capital. And the balance, in other words, if we take that away from 100, we get 34.13 that went to interest. Okay, right. I think we've got one question left, which will give. Oh no, we've got 2 questions left. Okay, this question here, Mrs. Tulana, another friend of mine, she teaches at Senzobuhle School. She borrows 50,000 rand. All right, interest of 10% per annum is charged, and she makes monthly payments of that. Okay, right. So it's a loan. It's a loan, so we're going to be using this formula. PVX 1 minus 1 plus I to the minus n over I. All right. And now, the loan is 50,000 rand. We know the repayments this time. The repayments are 1,000 rand. Interest rate is 10% per annum, but compounded monthly. Sorry. 1 plus 0.1 over 12 right, to the minus n over 0,1 over 12. Okay, and what we actually see now is that what we don't know is n. We don't know how many payments you must make, right? And I'm hoping many of you are thinking logs are going to be involved here because we're solving for an unknown exponent. Right. Remember the pass the parcel metaphor for solving equations as well as the balance metaphor, right? We want to undo and get n out of this absolute quagmire that it's in, right? So what we're going to do first is we're going to divide both sides by 1,000. We get 50 equals all this stuff. Little tide. 0,1 over 12 to the minus n over 0,1 over 12. Okay, we've got this fraction here. We don't like fractions. Let's multiply both sides by 0,1 over 12. And that will leave us on this side with 1 minus 1 plus 0,1 over 12 to the minus n. Now what I'm going to do is I'm going to take this and I'm going to add it to both sides. All right. And when I do that, it will now be a positive thing here on this left-hand side. So in other words, it'll be 1 plus 0,1. 1 plus 0,1 over 12 to the minus n. Okay. What I'm also going to do, just for kind of efficiency's sake, I'm going to take this thing and I'm going to subtract it from both sides. So in fact, what I'm left with on the right-hand side is just 1 minus 50 times 0,1 over 12. Notice I'm not working these things out yet. Okay. Now only am I going to take this thing into log form. Right. So negative n is actually going to be equal to log, remember the base is always the base, is the base, right? So the base is going to be down here. The base is actually, it's quite hectic that we've got a base like that, but it doesn't matter. We've got a calculator that's going to sort it all out for us. 1 plus 0,1 over 12, right? And the thing that I'm actually finding the log of is 1 minus 50 times 0,1 over 12. Okay, and let's bring up our calculator, hold a deep breath, and see what answer we get. Right, hopefully we haven't made any silly errors here. So 1 plus fraction button 0,1 over 12, and then in here we've got 1 minus 50 times by fraction button 0,1. Don't do that. 0,1 over 12. All right. I'm expecting a negative answer. All right. The reason I'm expecting it, it's looking very close to 65, and it did so to the nearest month. Remember that that's negative n. So in fact, n equals 65. And here we would round up anyway, because you wouldn't be able to get away with fewer than, you wouldn't be able to round it down. Even if it was 64,1, you would round up to 65. There would be a 65th payment. In reality, the 65th payment would actually be slightly less, and we could work it out. It's not hard to work it out. The easiest way of working it out would be to work out the outstanding balance after 64 payments, and then just put 1 month's worth of interest on that last amount that's still owing. See, if you understand what you're doing, you can solve any question. And that's why I hope that the little schematic of how a loan actually works was helpful. Right, the last thing we're going to talk about is a thing called a sinking fund. And it's really, really straightforward. A sinking fund is always a future value. All right. So it's a future value annuity. All right. And what it's for making provision for the replacement of an expensive item. Right. So rather than buying a kind of a 5 million rand piece of equipment, waiting till it's totally stuffed and then be able to get nothing for it and then trying to find 5 million rand to buy a new one, we actually make provision for it. So So what we need to work out here, and you'll notice I don't spend a lot of time reading the questions. I'm hoping you guys have read them beforehand. But basically, he buys a note, he buys a TLB, and that's what it costs. And he's going to replace it in 5 years' time. But now what's going to happen in the 5-year period is that this existing TLB is going to depreciate. It's going to lose value. And we're told how it's going to lose that value. All right. But also, sadly for Nati, a new one is actually going to get more expensive. Okay. In 5 years' time, he'll be able to trade in or sell his existing one, the old one, for what it's worth. It's not going to be worth very much, but for what it's worth. Okay. Now, he is going to have, in 5 years' time, if he doesn't make provision, he's going to have a shortfall. All right. A shortfall, which is how much he's going to be short. All right. Because he's going to be short of the price of a new TLB, 125,000, so 1.25 million, right? And it's unfortunately increased due to inflation. And remember, I said right at the beginning, inflation is always compound, and it's 5 years, it's compounded annually. Okay, we can work that number out. Now, what he's going to be able to save is the value of the depreciated value of his existing one. Now, remember, depreciation, we told which method to use, either straight line, which is the simple interest one, or reducing balance, more commonly. This one's reducing balance. This is 1 minus 0,075. That's 7.5%, also 5 years. In terms of saving yourself a little bit of time on the calculator, if you were to work these numbers out, right, you actually could factor out the 1.25 and just put it outside a bracket. Right, to save us a little bit of time. Now, I'm going to tell you that this actually all comes to 826,483, say 483 and 95 cents. Right, this is, if he doesn't save any money, that's how much he's going to need to find in 5 years' time. And now the simplest part of this is actually, he's just going to use a sinking fund, which is a future value annuity, to save this money. And we told over here that the sinking fund is going to earn interest at that, all right, and he's going to make monthly payments. So here's our formula. 1 plus I to the power of n minus 1 over I. Okay, and the amount that we need to raise is 826,483 and 95. And this is x, which is what we're going to work out. And this is going to be 1 plus, our interest rate is 0.09, but I need to divide it by 12, right? And he is going to make monthly payments for 5 years, 60 minus 1 over 0.09 over 12. And we solve this for x, and we get his monthly payment into this sinking fund is around 10,000. Not around, it's actually exactly 10,955 and 35 per month. Okay, and when one is doing these calculations, this is a really cool time to use your memories on your calculator. Okay, the store recall. Use your A, B, and C. And what I do as a little sort of strategy is when I work, let's say I'd work this number out over here, this piece, I would kind of put a little circle next to it and say, I've stored that, and I've stored it in A. Okay, folks, that brings us to the end of today. But before you sign off, if I can just say the following. All right, I'm pleased with the uptake. Obviously, I realize that this time of day doesn't suit everyone, but people are watching the videos. You will see that I've changed the order of the sessions at the request of a few people. The website is up to date now. I was alternating paper 1, paper 2. I'm going to finish all the paper 1 topics. That is because some of the students are some of you are going to write paper 1 before I was planning on finishing, because obviously the DBE and the IEB exams are at slightly different dates. Okay, but can I also say that if this is adding any value to you whatsoever, please like it. All right. Um, I think nearly 600 people have watched my first video on solving equations. No one's disliked it, but only 18 people have liked it. And actually 18 out of 600 is I'm failing. Okay, so please like it. Please share it with your friends. Please tell them about it. All right. There's no reason why everybody can't do well at maths. And so yeah, thanks for being with me and have a good evening. And tomorrow, looking forward to some calculus. Really, really, really cool topic. Okay, cheers, guys.